This video will focus on finding the domain of rational functions. From college algebra, we had two questions we wanted to answer about functions in terms of their domain. The first being, are there any even radicals within the function? So that could be anything in the form f of x equals the fourth root of x plus 5. Now, notice it has a 4 here, so it's an even number. That's what this even part means: a square root, a fourth root, a sixth root. Within the confines of rational functions, though, we're not going to focus on this one as much. Our main focus is going to be down here, where the main question we're going to have is, when is the denominator 0? So notice this one has a variable in the denominator. Our main focus will be when this guy equals 0. That's the question. Now, we have 4 steps that I want to look at after this. And here the 4 steps are. So the 4 steps are basically factor the numerator and denominator. Now, I will admit factoring the numerator right now doesn't help you as much as it will later. So it's really good to get in the habit of doing it in the beginning and already having it done. The focus after that is to determine where the denominator is 0. So what x values will give me a 0 if I plugged them in. After that, I want to exclude those values from the domain. And then we want to write our domain in the appropriate notation. Within this course, appropriate is typically going to be interval. And we will cover that in our first example. Now, our first example will be find the domain of the function x plus 3 over x squared minus 9. Now, we will have the numerator, so we'll factor that if we can. In our case right now, it's a really simple numerator. He's factored as much as possible. However, from there, we'll also need to look at the denominator. Now, this is a difference of squares, x squared minus 9. So that can be rewritten as x minus 3 times x plus 3. And now our goal is going to be, where are these two 0? So what we're going to do is take x minus 3, set it equal to 0, x plus 3, and set that equal to 0. And then we're just going to solve these two and exclude the answers from our domain. So add 3 to both sides. This one becomes x equals 3. Subtract 3 from both sides on this next one. And we have x equals negative 3. Now, with domain, so the domain of f, with this, we're basically trying to say x cannot be negative 3 or 3. Which, in interval notation, is going to look something like this. Alright. In this scenario, I have to start from the lowest value. So, domain starting from lowest value. We start at negative infinity. I can go all the way up to negative 3. And then I have to jump over it. So parenthesis means I can't actually use the number that's right beside it. From there, it's 3 to 3 and 3 to infinity, right? So once again, notice I jump over the number 3. At no point did I use brackets. So just in case, these two are union symbols. They're basically addition in terms of anything from this guy and anything from this guy and anything from this one. This is all numbers between negative infinity and negative 3. So as small as you want to go. Anything between negative 3 and 3, 0, 1, 1.9. And then anything above 3, 3.01, 1 million, so on and so forth. So in our case, this would be the domain. You're going to do this every time, and you don't want to cancel anything when you're doing this problem. So what I mean by that is if we go back, the numerator and the denominator have something that can cancel, the x plus 3's. In terms of domain, do not cancel anything. Other than that, that should conclude domain for the time being.